So today we're going to focus on graphing linear functions written in slope-intercept form. So slope-intercept form, again, is different than standard form. Standard form is just kind of the basic, simplest way that a linear function is written. And slope-intercept form gets a little bit more specific. By its name, slope-intercept form gives us two pieces of information. It's going to tell us the slope and the intercept of that line. Specifically, it's going to give us the slope and the y-intercept. So think of this form as being like the ingredients. It's going to tell you those two pieces of information that we can then use those two pieces of information to graph. So slope-intercept form, again, is always going to look like this. It's always going to be y equals mx plus b, where y represents the output of my function, x represents the input of my function. You're always going to have in every function y and x. M is going to represent your slope, and B is your y-intercept. So the two ingredients you're going to have, again, are your slope here and your y-intercept. So graphically, what do those things represent? What do they look like? So the slope, we're going to get into that a little bit, but a slope is going to describe the steepness of the line. Okay, so it's going to look at the steepness. So one, it's going to look at how steep it is. Okay, is it kind of a level line, or a near level line, I should say, or is it a very steep line? And then also, is that slope positive or negative? Meaning, does it go up or down? That's what the slope is going to tell us. And the y-intercept is essentially going to tell us our starting point. Okay, based on what we just talked about with standard form, the y-intercept is the location on my graph where x is 0, and then I'm going to have some y value. So again, this is going to be my x, and that's going to be my y. The way I like to think of this, again, is think of your y-axis as almost like the middle part of your graph, that the y-intercept is going to find that middle point where the line crosses the y-axis. We're going to treat that as the starting point of this line. Now, the most important part of slope-intercept form, again, the y-intercept is going to tell us where to start, but the slope is going to tell us how I get to every other point on my line. Remember, what makes a line unique are simply 2 points, where it starts and the next point after that. That's going to determine what the line is going to look like. So the slope is important because it's going to tell us, again, how steep the line is, and it's going to tell us whether the line goes up and down. So the slope of a line is going to be the ratio of how much the line goes up or down versus how far it goes over. And again, that's going to look at the steepness of the line and also whether it goes up or down. So the two things that are important here are, first, you have what's called the rise. The rise is going to be, it says here, the change in y. Think about that as how far the line goes up or down. And then lastly, you have the run. So the run is going to be the change in x, and that is how far the line goes over. Okay? So, for example, you'll see this line here. We have a line going between 2 points. The rise is going to tell you, shown here by the red arrow, how far from this point to the next point, how far it goes up. And from this point to this point, the run would represent how far it goes over. So notice here the run is longer than the rise. So this line is not that steep. If I were to make changes here, let's say I make the rise larger, it's going to make that line steeper. And if I were to make this run shorter, it's going to make it even more steeper. Get it? More steeper. So the rise and the run are going to be those two things that are going to tell you what the line is going to look like. And heck, if I flip this rise upside down and make it go downward, that means my line is going to be negative. It's going to go downward. So the way I always think about the slope is again going to look at the rise and the run. Slope is symbolized again with that letter M. Why M, I don't know, but it's going to look at the two things, rise and run. The rise indicates the change in y, and the run indicates a change in x. Now, what's meant by the change in y and change in x is if I take the actual values of my points, all I'm doing is subtracting, okay? So if I were to just make up values here, let's say that this y value is 8 and this value is 2, well, then the change in that would be 8 minus 2, which would give you 6. Same thing for the run. The run is going to be that change in x, which is going to look at the difference between my x values. So let's say that this x value, I don't know, we'll make it up as 6, and this one, since it's behind the y-axis, is -1. If I were to subtract those, 6 minus -1, well, that's going to give me 7. So then the slope would be indicated as 6 over 7. Now to bring this up, you're going to see slope written as a fraction. And I know sometimes we freak out when we see fractions, but this is actually okay. These numbers have meaning to it. The 6 tells me how far it goes up. The 7 tells me how far I go over. If this 6 was a negative 6 over 7, that just means it would go down 6 and right 7. Okay? Now, last thing here, is it possible to have both of these negative? Negative 6 over negative 7. It is possible, but here's what ends up happening. Negative 6 over negative 7 in terms of meaning would be down, and instead of right would mean left. Now, what happens, though, when we see a negative divided by a negative, usually that results in both of those numbers becoming positive, because two negatives cancel out to make a positive. So what ends up happening is the line is going to go up and right. So we are never going to leave a negative denominator as one kind of rule of fractions. So the denominator is always going to be positive, which means we're always going to be moving to the right on our graph. We're going to read a graph like we read a book going left to right. The thing that's going to make the big difference is the rise and whether it goes up or down. Okay, and then the second variable we looked at again was the y-intercept. Kind of already talked about this, but again, the y-intercept is going to be that point on the graph, symbolized B here, where my x value is equal to 0, and then I have my y value. Okay, the way I like to think about this is my starting point. So when I graph a function, I'm always going to find that y-intercept, which is going to be the point on my graph where it crosses the x-axis. Or sorry, the y-axis, not the x-axis. So once I know where that point is, then what I can do is simply apply the slope. So in this case, the slope is going down. So once I know where that starting point is, then I can apply my slope down and over, and it's going to tell me where the next point on my graph is going to be, or on my line. Okay, so the y-intercept is that next piece, and again, it goes back to what we talked about in standard form. It's that point where the line crosses the y-axis. All right, so let's take just a quick little example here on using graphs to find the slope and the intercept. So in this case, I want to indicate from the graph what is the slope and the y-intercept of each of these lines. So the slope, again, is going to be that value m, and the y-intercept we'll label as b. Start off first with the easy one, the y-intercept. Where does it cross the y-axis? Well, it crosses here at -2. So as a point, x is going to be always 0, and my y value is going to be -2. What I then need to do is apply my slope. Now to apply my slope, what I'm going to do is I'm going to look for the next point. And I can find, I can look at any point, I can find the next point. But when I say a point on a graph, where I'm looking for, and I'll just pick a random one, is where does the line cross between the corner of those boxes? Okay? So it's got to hit at a corner. You can't just pick a random spot such as right here in between boxes. That's not going to work as a point. All right, so if I just choose this point, and then I look from point to point, well, this line goes down 2, and then it goes right 2. I'm always going to count by going up or down first and then moving right. So in this case, down 2 and right 2. Well, that's going to simplify down, folks, is -2 over 2 means technically -1 over 1, or just -1. Okay? So in this case, my slope is going to be -1. Now kind of backtracking, -1 as a whole number technically means -1 over 1. And also note that it also went to -2 over 2, but that would be my slope. Next example here, I have my y-intercept is right here at -2 again. So that means I have my y-intercept at 0, -2. And then to find my slope, again, I want to choose another point on my graph. So I'll choose just a random point. Let's say I choose a point right there. Okay? I'm going to choose this point just to show you guys kind of what I was talking about before. But if I want to go from point to point, the way I want to do this is I want to start, even though, yes, this is my y-intercept, I want to read this like a book. So I'm going to start with my leftmost point, and that would be this point right here. So what I'm going to do from that point is I'm going to go down again, and then I'm going to go over. And then counting boxes, this just means I'm going to go down 2 and right 1. Now down 2 and right 1, that would simplify down to -2. So in this case, my slope would be -2. All right, I want you guys to try this last one on your own. Pause the video, find the slope and the y-intercept. All right, so what you should get is a y-intercept of -1. Your slope should be 2 over 5, up to right 5. 2 over 5 cannot be simplified, so we're going to leave that as a fraction. Don't be afraid of that fraction because remember, it has meaning in this case. Our next example is pretty easy. It's just identifying slope and y-intercept from the actual function itself. So again, we're looking at slope-intercept form, so you're going to have to be able to look at these equations and identify the slope and the intercept, and then we can kind of combine into that then to actually graphing it. So we're trying to identify these from our equation. So again, slope-intercept form is y equals mx plus b. So the two things we're looking for are m and b. M is the slope, b is the y-intercept. So m is always attached to x, b is always by itself, as long as our y is alone on the left side. So in this first example, I have y equals negative x minus 2. So the number in front of the x, or attached to the x, is going to be my slope. Now notice there's not a number written there, so what that means is that actually my slope is going to be negative 1. Okay. Now what does negative 1 mean? Negative 1 means I'm going to go down 1, and remember I can always put it as a fraction over 1. My y-intercept then is going to be the number by itself, so that would be the minus 2. So my y-intercept b is going to be the point of 0, negative 2. We'll plot that point then. For the next one, same idea here. The number in front of x is my slope. The number by itself is the y-intercept. So in this case, I'm going to have a slope of 1 over 2, which means up 1, right 2. And then my y-intercept is going to be negative 1, which again is 0, negative 1 is the point where x is 0 and my y value. All right, I want you guys to try this next one on your own. What would be the slope and the y-intercept for y equals negative 2x minus 2? All right, so you should get a slope of negative 2, which means negative 2 over 1, which again means down 2, right 1, and a y-intercept of negative 2. All right, so again, identifying them from the equation. All right, now once we know the pieces, it's time to graph. So now what we're going to do is kind of just take it simple. Well, let's say I give you the slope and the y-intercept. How do we graph them? So the best way to do this is we're going to start first with the y-intercept, okay? So our number one thing here is going to be start with the y-intercept. So the y-intercept here is 1. Now as a point, remember, that is going to be 0, 1. It's the point where my x value is 0. That would be right here in my graph. So we're going to start there because that's my starting point. Shows where the graph is, or where the line is crossing that y-axis. The second thing I'm going to do then is apply my slope. So my slope here is 2 over 3. So 2 over 3 means I'm going to go up 2 and right 3. And I'm going to go up 2 and right 3 from that point. So up 2, right 3 would put another point right there. And what I'm going to do is I'm going to try, just for my sake, because I'm going to apply the slope a couple 2 tree times. Get it? Couple 2 tree. Oops, that's one off. Just so I can see what the line looks like. Once I get plenty of points and I can see, okay, my line is going to look something like this. So when we graph these, we're always going to start first with the y-intercept and then apply the slope. All right, second example, slope of 2, y-intercept of negative 4. So again, negative 4 means I have a point of 0, negative 4. So down here. And then my slope is 2. I'm going to write this below. Slope of 2, okay? We want to view this as a fraction. Slope is rise and run. So I'm always going to write this as 2 over 1. Anytime I see a whole number, put it over 1. Because what that means then is my line is going to go up 2, and it has to go over. So it's going to go right 1. So from this point, I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. To apply that in reverse, I'm going to go down 2, left 1, down 2, left 1. Kind of the same thing there. So I can get my line and then, boom, be able to draw it with my arrows going both ways. So again, y-intercept and slope. Now, putting this all together, we're going to graph these things given the equation. So if I have y equals 1/2 x plus 3, all I'm doing is identifying my part. So I have y, or 1/2, and I have the plus 3. So again, to identify these things, the 1/2 is my slope, which means I'm going up 1 and right 2. And the 3 is my y-intercept, which again is going to be a point of 0, 3. So I'm going to start with my y-intercept first. And then from there, I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, apply my slope. And again, I can do the same thing in the opposite direction by applying the points in reverse. And again, drawing my line, shebang, shabop, we're all done. Okay, next one here, we got negative 3/2 x minus 1. Again, this one looks a little goofy with the fraction, but we have negative 3 over 2. That's just how I had to write it on this, folks. But that means that is my slope. So my slope here is going to be negative 3 over 2, which means down 3, right 2. Quick side note, when I see this negative, always apply it to the top number. So that top number is going to be the negative, not the denominator. We always want to go to the right. And then again, my y-intercept here is going to be negative 1, which means it's a point of 0, negative 1. So starting at negative 1, I'm going to go down 3 and then over 2, down 3 over 2, down 3 over 2. And to go in reverse, I can go up 3 over 2 as well. And then again, up 3 over 2. And once I get enough points, then I should be able to get a sense of what my line looks like, and then connect the dots. Okay, last two examples here. The first one, we have negative x plus 1. So why don't you guys try this one on your own? Okay, be careful here with that negative x in front, but what would be the slope in the y-intercept, and then graph it for me, please. All right, so the last one started at 1, and then my slope was negative 1, which again, since it's a whole number, wrote that negative 1 over 1, which means down and right. So from this point, down and right 1, and also up and left 1 is the same thing to continue that line. All right, last example here, we're going to do this one together. Notice here, rut-row SpaghettiOs, folks. Holy strawberries. That's not written in slope-intercept form. That's written in standard form. Now here's the nice thing. Once we know how to graph things in standard form, we should hopefully remember how to graph this equation. But I want to show you guys, if you don't, let's say you forget or don't remember, and you like graphing in slope-intercept form better, we have to be able to, in order to graph this in slope-intercept form, we have to make this equation look like slope-intercept form. Slope-intercept form, again, looks like y equals, and then you have the rest of your equation. Now notice on the left side here I have 2x minus y. So that doesn't say y equals. Now in order to make it say y equals, I'm going to have to move some things around. So let's keep the y on the left side. So I'm going to start first by getting rid of that 2x, and I'm going to move it to the other side by subtracting. That's going to cancel here, and I'm going to be left, as I'll write it up top, negative y. Now why negative y? Because that negative right there is attached to the y. And that's going to equal then, I'm going to write this as negative 2x plus 6. The reason why I'm going to write it like that is to keep the order the same. Notice the negative 2x, the positive 6, I'm just going to write it in that order. Now, it looks like we're close to being done, but we've never graphed in negative y. What we need to do is get rid of that negative sign. Think of there being a negative 1 in front. So to get rid of that negative 1, we're going to divide both sides by negative 1. All right, now once we simplify, we're going to have y equals negative 2 divided by negative 1. Both of these are going to turn positive, so that is going to be 2 over 1x, which would just be 2. I'm going to leave it as 2 over 1 just for funsies. And then 6 divided by negative 1, keep it as a 6, but it's going to turn into a negative. Now again, why I kept that as a positive 2 over 1, because that's my slope. That's my y-intercept. So hopefully if you're good at recognizing these now, it's going to start at negative 6, and then it's going to go up 2 over 1, and I can also do down 2 left 1 to continue that line. And shebang, shabop, we're all done. All right, folks, make sure if you got any questions, jot those things down. We'll see you next time. Peace out. Okay, last problem here. We have a roller coaster car ascends the first hill of the Raging Bull at Six Flags, one of my favorite roller coasters. It says here we have the elevation h in feet of the car is modeled by the function h of t equals 5t plus 25. So recognize there our function notation where h represents the height in relation to time. So obviously time in minutes. So we have height in feet, time in minutes. And it says for the car to ascend the hill, which means to climb that first hill. If you guys ever been on that, that's when you leave the platform and you go tick, 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 all the way up to that very first hill before you drop. It says it takes the car 15 seconds to reach the top of that first hill. So our goal is to take this equation written in function notation, written in slope-intercept form, first to graph it and then to identify domain and range. So to recognize first the graph of the equation, y equals mx plus b. Notice it's written in function notation, so instead of y, we have h of t equals 5t plus 25. So don't get fooled, but our slope here would be 5, and our y-intercept here would be 25. Even though it's written with different letters, it's still the same form. So to follow my graphing rules, I'm going to start off with my y-intercept, which is a point of 0, 25. I'm going to plot that point on my graph. And then my slope, m, is going to be 5 over 1, which means up 5 and right 1. So on my graph then, I would have then up 5 over 1 going through my graph. And I'm going to plot as many points as I can here. And this again is showing as the raging bull is going up that first hill. It's climbing the hill, which you can see there by that graph. What I then want to do is recognize, based on this, what are my domain and my range. So again, domain is going to be a list of all of your inputs that are possible, and the range is going to be a list of all of your outputs possible. So in this case, we have the roller coaster car ascending the hill. So if I think about my x values, my inputs, using my graph, you can see here that it starts from 0. Because we're talking about time again, it would not make sense for my time to go below 0 to the negative realm. So when I think about my time, it's going to start from 0. And then it says it takes the car 15 seconds to reach the top of the hill. So the maximum time here I'd have is 15. Now because x is representing the time, instead of x, I'm going to use t. And again, I'm going to write this as a compound inequality. So what that would mean is that the time it takes to reach the hill would be between 0 and 15 seconds. In terms of my range, you'll notice here on the y values on my graph, I start at 25. And very similar to my time, I'm going to reach the top of the first hill. The only issue here is my graph stops at 10 seconds. And I want to know then, what would be the height of the hill at 15 seconds when I reach the very top of the hill? So what I would need to do in this case, in order to find that maximum range value, is I'd have to plug 15 seconds into my function here where t is. I'm going to take that as an input and figure out the output. I'll show that here below. So if I do 5 times my time value of 15 seconds, and then plus 25, that's going to give me my output, which in this case would be 100, and that's going to represent 100 feet. So that means my minimum value is 25. The maximum value in terms of my height is 100. I'm going to throw h in the middle to represent height, and again, show this as a compound inequality by using the less than or equal symbol. And what this means is I start at a height of 25, and I go all the way up to 100. Now lastly, it says to interpret the slope and the intercept. So in this problem, the slope is given to you as 5 over 1. So 5 over 1 on a graph means up 5 over 1. Now when we think about the meaning of the slope, what is going to give us meaning is the variables that we're talking about in this problem. So on my graph, it goes up 5 and over 1. So the 5 represents 5 feet. And the 1 is going to represent 1 second. So if I think of the units associated with those numbers, it would be 5 feet every 1 second. Now, what does that mean, 5 feet every 1 second? Also, you can think of this as 5 feet per second. This is going to represent the speed of the car as it goes up the hill. 5 feet per second is not very fast. That's okay. Same thing with my y-intercept. I had a y-intercept of 0.25. So this being a y value would represent 25, whoops, not 2 feet, but would represent 25 feet. And think of this as your starting point. So this might represent here the loading platform. If you've ever been on a roller coaster, you know that you don't start from the ground, but you climb those stairs to the loading platform, and then it takes you up the first hill. So in this case, you were 25 feet above the ground before you even started going on the roller coaster. So there's a little application problem of graphing things in slope-intercept form.